Hello, Namaskar and very good afternoon to all the viewers connected with us on NCERT's live and interactive program. I am Anu Gupta, your host for this session. Dear viewers, you are connected with us for this 1 hour for class 12 session of mathematics subject. I wish to tell you that you are connected with us through PMA Vidya channel number 12. Apart from that, if you wish to connect to us through other mediums, we are also streaming live on our YouTube channel, which goes by the name NCERT Official. You can post in your queries, questions and your answers in the live chat box, and our experts will get back to you as soon as they receive your comments. Dear viewers, I would also like to tell you that we are connected with you through telephone also, and our telephone number through which you can connect with us is flashing on the screen right now, and it is 8800 440 559. Also, if you wish to write to us in detail, please note down our email address also. It is class specific. It is dth.class12@ciet.nic.in. I have told you all the mediums to reach out to us. So, let us come back to the topic that we are going to discuss today in the mathematics session for class 12 students. So, मेरे प्यारे बच्चों, आज हम आपके लिए लेकर आए हैं वेक्टर अलजेब्रा, एक ऐसा टॉपिक जो आपने फिजिक्स में शायद कक्षा 11वीं में पढ़ा होगा। और आइए थोड़ा सा जानते हैं वेक्टर्स के बारे में। मैं अपनी समझ से आपको बताना चाहूँगी, यदि एक एरोप्लेन आप स्पॉट करते हैं, इफ़ यू स्पॉट एन एरोप्लेन एंड इट इज़ मूविंग टुवर्ड्स ईस्ट डायरेक्शन at the speed of 800 kilometers per hour, we could say that it's a vector. We see vectors all around us. और आज हम पढ़ने जा रहे हैं वेक्टर अलजेब्रा के बारे में, और इस टॉपिक को डिटेल में हमें बताने जा रही हैं हमारे साथ जो एक्सपर्ट जुड़ी हैं, उनका नाम है डॉक्टर बीना प्रकाश. I welcome Dr. Bina Prakash ma'am in the session. Namaskar ma'am.
Good evening to all my learners and Anuji आपको भी.
Thank you so much ma'am. Ma'am is senior PGT mathematics in Campion School, भोपाल. तो अब मैं बिना देर किए आपको ले जाना चाहूँगी वेक्टर अलजेब्रा की दुनिया में डॉक्टर बीना प्रकाश के साथ. मैम
आपने सही स्टार्ट किया, पर इसमें ये था कि एक्चुअली उस एरोप्लेन का आपने एक फैक्टर बताया, इट इज मूविंग एट अ स्पीड, ठीक है, वो स्पीड को बताया, स्पीड आपने बताया, एंड अलोंग विद दैट आपने एक और चीज बताया, दैट इज नोन एज इट्स डायरेक्शन.
राइट.
तो ये दो इंफॉर्मेशन जब टुगेदर रहते हैं तब हमें इस वेक्टर बोलते हैं.
यस.
Like many of the quantities around require only one factor, like mass, distances. कोई distance है एक जगह से दूसरी जगह का, भोपाल से दिल्ली का distance है. It is only a quantity that is describing temperature. अभी का temperature, what is that temperature? Cost of some element, that's in 1 unit. तो ये सारे unit इसमें है. We have only one factor that is known as magnitude. Whereas velocity, when you said about aeroplane, the plane flew at the speed of something in this direction, एक direction दिया है, तो उसमें direction के साथ हम अगर बात करेंगे, then that is known as vectors. So anything associated with magnitude as well as direction is known as vectors.
Right.
तो मैं हर बच्चों को ये बोलती हूँ, each child is a vector because they do have magnitude, उनके अंदर strength है, and they need a direction so that their magnitudes can be increased. So हर बच्चों का हर बच्चे को वेक्टर के फॉर्म में मैं देखती हूँ और उनको मैं बताती भी हूँ ये क्लास में.
That's wonderful example, ma'am.
That's apart from the chapter. So the definition is that which has only magnitude, that is known as a scalar quantity. So you can see that which has only magnitude is known as a scalar quantity. Which has both magnitude as well as direction is known as vector quantities. Okay? So the basic information of vectors, actually they have, most of the children, आप लोग को ये मालूम है, since 11th में ये हमने चालू किया, क्योंकि physics requires both these quantities. Most of the physical aspects that we have, they require direction as well as the magnitude. So the vector as such part has been introduced. We'll be taking things in detail. Like अब यहाँ पे आपको दिख रहे हैं different types of line. This is simple line. This is a ray. This is a ray which says that it seems to start from one point, it is going in this direction. This one is going in the other direction. Here it has been specified, that is, it is passing through these 2 points A and B. So these are different ways of expressing a line. तो इन सब में क्या दिख रहा है आपको? L जो line है, it has, in the first वाला जो line है, it is just a part of it. That is, कहाँ से आ रहा है, कहाँ जा रहा है, no direction. कितना है इसका मैग्नीट्यूड, दैट इज ऑल्सो नॉट स्पेसिफाइड. बट एल एंड एम में डायरेक्शन तो है, इट्स गोइंग डाउनवर्ड, एरो दिख रहा है, ये अपवर्ड एरो दिख रहा है, डायरेक्शन, बट मैग्नीट्यूड नहीं दिख रहा है. तो मैग्नीट्यूड इज स्पेसिफाइड इन दिस एग्जाम्पल. देखो यहाँ इट इज पासिंग थ्रू ए बी, तो ए एंड बी इज द स्पेसिफिक पॉइंट. सो द लेंथ ऑफ ए बी डिफाइंस द मैग्नीट्यूड, और डायरेक्शन इज दिस लाइन, डायरेक्शन. So that is taken as a vector quantity. That means उसका एक initial start point होना चाहिए and उसका terminal point होना चाहिए. So like here the last one, we find that it starts from A and then it goes towards B. So that's the direction that we have. So it's a vector quantity which is represented as A to B. That is एक arrow दिख रहा है हमें. That is the most important thing that defines a vector quantity. That is, it is specifying the direction, and the direction is from this is known as the tail of the arrow, this is the head of that arrow. तो tail की तरफ कौन सा element लिखा है, alphabet लिखा है, that's the starting point. Head की तरफ कौन सा alphabet लिखा है, that is the head of the that is towards that it moves. ठीक है, that is using 2 alphabets of English alphabet, and we prefer to use capital letters. अगर हमें एक representation that is small letter a लिया है, this represents the whole of this vector, that is a. And it has direction, that is हमने इसके पर लिखा है, it is going towards, the arrow specifies the direction. Magnitude is length, that is distance between A and B, and इसको लिखने का तरीका is between 2 vertical bars, vertical lines, the magnitude of A or simply A, that's all. ये है तरीका लिखने का है for magnitude. Fine. Now we need to discuss about types of vectors. How can we differentiate different types? Types of vectors starts from co-initial vectors. Co-initial vectors, it is very clear from the word co-initial. That is the vectors which have same initial point. Like you can see this vector, this is a vector quantity O, and it start, if it is going towards P, so we represent this way. So it is the vector OP. This is the vector I'm talking about. Fine. There's another thing, line, when a ray you can see which starts from O, and that is passing through Q. So that's another vector quantity. Both these have the same initial point. That is, O is the initial point. So that is known as co-initial point of the vector. Fine. So OP and OQ are vectors with same initial points. Fine. So this is a type of, these informations are required for further part, that is algebra जब हम discuss करेंगे तो उसके लिए we require all these informations.
Alright, so we have another information for you. I would like to introduce our sign language interpreters with us. You already are looking at one. I welcome you, Ms. Rimpi, and we will be joined by another sign language interpreter in some time, Ms. Rashi. Thank you so much for joining us today. And yes, Bina, Prakash ma'am, please continue.
Now here you find there are so many vector quantities. You can see that one vector starts from O and it is going towards Q. So this is the vector OQ. And there is another vector O through P. So that's another vector OP. And this is another vector, third vector OL. And you find OM, that's this vector OM. All these vectors, they have the same initial point. That means we can describe a vector from a same point. मैम आपने जैसे स्टार्ट किया था एग्जाम्पल एरोप्लेन का, we can always discuss this way कि one plane starts from Delhi, New Delhi airport, it goes towards Japan, the other one going towards Turkey, the third one going towards California. So they are all going to different directions,
right? But
they have the same starting point. Their directions are different, and the length, distance also will be different. So they are all different vectors.
Right.
Okay. So this example must have cleared the definition of co-initial vectors. Fine. Now next is co-planar vectors. Now what are co-planar vectors? Planar means in a plane. It should be in plane. That is, the vectors that we are discussing should be in one particular plane. Fine. Now I have this plane. This is a screen is one plane. So I have kept one vector here. There's another vector moving in this direction. It can have any direction. These are two vectors. I'll represent this vector by A and that's vector B. Fine. Now I have another vector. So I can represent two vectors in this particular plane. So it's not necessary that it's only in the screen. I can have one in one direction and the other one, like I can use this palm. You can also see the screen. Can you see the screen?
Yes.
Here I have this notepad. I've kept one. This pen represents one plane, one vector. Okay, it is in this. Now I have another vector. This is another vector. I have to have the two vectors in the same plane. What do? I'll shift this plane and have such a way that both the vectors they lie in this plane. Fine. But the question is, when we have another vector, the third vector, two vectors we can always place in one plane. But when we have a third vector, it is not necessary that the third vector should, because the two vectors can form a plane, but the third vector is such that it is not necessary that it should be in this plane. It can be anywhere. So it is anywhere. It's not necessary all the three vectors should lie in this plane. Hence, it is if the vectors they lie all the vectors that is in the space they lie in one particular plane, then they are known as coplanar. Otherwise, that it's in the space. The vectors are in the space. Fine? Planes flying at different heights, moving in different angles. Reference point is Delhi. Planes moving in different direction from here to Japan, taking off from here and then from here to California. They're all in the different directions. But what is happening is we do not have a plane which can take up in both in the same direction, platform, the same platform. So therefore, they are known as coplanar if we are able to get vectors in the same plane. Is that definition clear?
Yes.
Now we have another quantity that is known as zero vector. What is the meaning of this word zero? Zero is the initial and the terminal point, they coincide. See, I move in this direction, I reach this point. So this is point A and that's point B. So I traveled certain distance. Got it? And I have been displaced from this point A. The point A from where I started has been displaced. I reached this point B. So here the distance and the displacement, they are the same thing. Now see the same thing in different way. View it in a different way. I am at this point A. You can see the point on this. And then I am moving on this circle, getting back to the same point. Distance I have covered, but what is my displacement? How far I have moved from my place. So this is the starting point A and that's its ending point B. So what we see here is it starts from A, goes to B, it is up to B. So you have some length to cover. There also we have some length to cover, but finally you're back at the same point. So the displacement is 0. Understood? Hence this is represented as AA. A means starting point A, ending point A. So that is initial and terminal points both coincide. In that case, such vectors are said to be a zero vector. And they are usually represented as capital letter O, put an arrow over it. So this needs to be specified when we take up algebra part. I suppose this is made clear to all?
Absolutely, ma'am.
Yes, shall I move further?
Ji.
Now next is the unit vector. Unit word stands for 1. Unit means here refers to the magnitude. That means a vector which has magnitude 1. A unit vector is a direction in the direction of any vector given. Its length should be 1. Fine. The representation is within the bracket. Its magnitude is 1. So for any vector, to get a unit vector, what we do is divide the vector by its magnitude. So that vector form will always be a unit vector. Okay? Now here, this will be explained. I'll explain that clearly with following examples and all. Now here, we have specific unit vectors, which is represented as I, J, A. any vector which has a cap over it. If a cap is written over a vector, this representation is meant for unit vector. So I have put a cap over I, cap over j, cap over k. They are known as unit vectors. What is so specific about it? Since they are unit vector, their magnitudes are 1. That is fine. But they are the specific vectors which are in particular in directions of the x-axis, y-axis and z-axis of the Cartesian system that we have. We have this three-dimensional system, x-axis, y-axis and the z-axis. So along x-axis we have this unit vector I. Now what is the purpose of this unit vector? Now you all can see this point. We can read this point. This is 1, 2, 3, 4. This point represents 4, 0, 0. So if I need to mark this point, I'll mark it as A. Let me mark it as A. This is the origin. So O to A, the length of it is 4 units. Fine? That's okay. Now I need to make it vector. I have to have a vector in that form. That is, I have to show a direction. This direction is x-axis, which is explained through this vector, unit vector I, which has magnitude 1. So how do I convert this quantity into a vector? By adding I to it. So what have I added? I have added a vector quantity which is describing the direction. Its magnitude is 4 because the magnitude of the whole thing, I's magnitude is 1. So we have explained this in terms of a vector. Likewise, we have j in the direction of y and k in the direction of z. Now if I change the direction of I into the opposite direction, then that represents minus of I. So if you have a point A dash, which is having coordinate minus 4, so vector OA dash will be represented as minus 4 of I, because the I that we have is in the opposite direction. I specifies positive value which is in one direction, which is the positive direction OX, minus I represents the negative direction. So that's how we make a vector. I suppose this part has been made clear.
Right, ma'am. Absolutely. Yes.
Now we have another term that is known as collinear vectors. Now what are these collinear vectors? The vectors having same direction with that of the directed line. That means a line will be given to us, and the directed lines, the vectors that we are talking about will be parallel to this directed lines. So when we talk about the set of lines that you see here, we find that this is one line which is represented by vector. This is represented by vector W. This is represented by vector A. This is represented by vector V, and this by vector U. Now here we find that it starts from this point, it is going in this direction. It starts from here, it moves in this direction. The distances, you can see that these are parallel lines. They are all parallel lines. But what difference do you find in all these lines? There is some difference. Some are moving in the same direction, some are moving in the opposite direction. Some lengths are different. The lengths of each is different. So that is what I have shown here. The vector V and vector A, they are in the same direction. But the difference is vector A is half the vector A. Vector V is half the vector A. Likewise, if you compare U and A, you're comparing U and A, we find that vector U is 1/4 the length of A vector, and that too it's in the opposite direction. So it has been described in the negative form. It's minus of 1/4A. So the sign, everything matters. So what we see is vector U and W are in the same direction. They are in the same direction, whereas V and A are in the same direction. But all these are parallel vectors, collinear vectors. They are known as collinear vectors. Fine. Now here, A and V, W and U are opposite in direction. So they are known as parallel vectors, which is known as like vectors. W and V A and U, they are anti-parallel, so they are known as unlike vectors. So these terms you should be very familiar. So keep reading. आप लोग बार-बार इस terms को पढ़िए. You will remember this fact. There is nothing कि आप ये याद नहीं कर पाएंगे. आप 2-3 बार read करेंगे text book, ये part बहुत clearly explain किया है. And you need to know because questions are asked on the basis of these informations. तो हमें आप अपना क्लियर करना है कि लाइक वेक्टर्स किसको बोलते हैं, अनलाइक वेक्टर्स कब बोलते हैं, एंड सो ऑन. नाउ वी हैव मल्टीप्लिकेशन ऑफ ए वेक्टर बाय अ स्केलर. As you have seen that here, आपने यहाँ ही देखा u vector is multiplied by -1/4. -1/4 means a magnitude, a length, a value दिया है. That is multiplied to a vector. So that is known as a scalar quantity. So this is a scalar multiplied by a vector. This is a scalar multiplied by a vector. It's a scalar multiplied by a vector. So what happens is the direction and all, direction changes if it is negative value, otherwise the length of it will change. That's the only difference that we find. Okay? So the information that you are going to take from here is, if you come across collinear vectors, what you need to know is how to handle this collinear vectors. So the information that you have is, when A and B are two collinear vectors, then the relation is the vector A, that is one of the vector, can be expressed as some scalar times the other vector. It is some scalar times, and make sure that the scalar is not equal to 0. Otherwise, it's not equal to 0. So we are able to express a vector in terms of the other vector in terms of a multiple of scalar. Then that two vectors can be set as collinear vectors. Fine? यहाँ तक किए. Now we move on to the algebra. That is, we start now the operations that we have in mathematics, that is addition. Let's take up the first operation, that is addition. Now the question is, how do we add two vector quantities? जैसे आप देख रहे हैं ना, ये vector है ये. This is a vector in this direction. It's another vector in this direction. Now the question is how to add the two vectors. They're two in two random directions. They have their specific direction. Now how do we add it? Addition means आप बता रहे हैं कि you are from one point to another point, and then from there it moves further. तो वो there it moves further को how do we express it, interpret it? तो इसको कैसे करेंगे? So that's what we have. That is, we take it one way. That is, you take this vector parallel. देखिए ये vector को मैंने shift किया parallel. I've shifted this vector to this place towards A. That is, A की तरफ हमने shift किया है. It is shifted parallel in such a way that the initial point of the vector B coincides with the initial point of the vector A. So we have now both at the same position. Now if that's the situation, then how do we move ahead? Now that's what we have to see. That is, we have two vectors which we have connected with the same initial point. The first task is to connect the two vectors with the same initial point. We did by shifting it parallel towards A such that the initial point of the B vector coincides with the initial point of A vector. Fine? Now this is not just enough. हमें इसको और आगे करना है. Because vector addition says that आप एक point से एक जगह गए हैं. Then from here you are moving further. यहाँ from the same point you have to move further to another point. So therefore the displacement that has been taken up is OB. That doesn't make any difference आप कैसे जा रहे हैं. O से A गए हैं. This is O to A in this direction, and from A to B it is in this direction. That is, from here Delhi to Calcutta, and then from Calcutta let me take it as Agra, and then here from Agra to Shillong. So from finally from Delhi, from where did you take up? From Delhi. How much you have to travel to reach Srinagar? That's what we have as a distance. So this displacement has been taken up. So for that we need to know from where the other vector starts from. So that means we'll have to again shift this vector parallel towards P such that initial point of it is the terminal point of the vector A. Getting my point?
Ji.
I am shifting the vector B parallel to the vector in such a way that the initial point of vector B coincides with the terminal point of vector A. So that gives us an information that is started from O, reached P, and then from P we moved to R. So that way the final displacement is from O to it has reached R. So R is the point from where it reaches. That is, R stands for this terminal point of the vector B now after the shift. So this whole system looks like a parallelogram. It's not looks like a parallelogram, it is a parallelogram because we have shifted it parallel. So these two sides are parallel. And then we complete this parallelogram. We draw a line which is again parallel to this side. So where it meets, that is the diagonal that we have, that is the fourth point of that parallelogram. It happens to be the diagonal OR, that is the same initial point we have. There are two diagonals of this parallelogram. One is OR, the other one is QP. So the sum of two vectors is the diagonal of the parallelogram it forms while we add, which has the same initial point. So the diagonal with the same initial point of OP and OQ will be the resultant of the sum of the two vectors. Is that clear? Now we are discussing about another aspect. Is A plus B equal to B plus A? That's another aspect that we are discussing. That is, we took this as A plus B, that is from O to P and then P to R. Can't we take up the other way? That is, we start from O, reach point Q, that is, you're moving on this path O to Q, and then from Q you move further to R. So the resultant is still OR. So whether you take up this path OQ to QR or OP to PR, anyway the displacement, that is the final terminal point, will be R. So it doesn't make any difference the path that is travelled. Hence it says that the vector addition is commutative. Is that clear? This fact, vector addition commutative, is this fact now clear? Now let us analyze this addition once again. We got the resultant of OP, OP, O to P, then P to R as OR. So that's the resultant that we have written. OP plus PR is OR. Now let us concentrate on this expression. OP plus PR is equal to OR. I'll bring the OR quantity to the left hand side. So when you bring it to the left hand side, it comes as minus OR. Now what is left on the right side? The quantity that is left on the right side is nothing, that is 0. So if I write this as 0, we have a wrong statement, because on the left hand side we have the combination of vectors. Right side, it's a scalar quantity. So that also needs to be expressed in the vector form. So that has to be expressed as 0, an arrow over it. This half arrow is also fine. Many of the students, they are supposed to write the full arrow. This is also okay. Now we have OP plus PR minus OR is a 0 vector. Now let us rearrange. Now we have seen that in the previous examples I have shown that A is one vector, that is A is moving in this direction. What does minus A represent? The same thing in the other direction, that is minus A. This represents minus A. So its direction has changed. So if its direction has changed, then in that case initial point and the terminal point, that it's moving in the opposite direction. So this change of initial and terminal point will change. So now initial point becomes R, the terminal point is O. So that change, with that change, what we have the expression as? We have the expression as OP plus PR plus RO. OP plus PR plus RO comes out to be just see the sum of it. OP plus PR is giving us OR. The resultant is OR. And then from there, R, O further. OP, PR, it is R. And then further back, R to O is back to the same point. It is back to the same point, that is O. Hence, the displacement is 0. So, the vector is 0 vector. So, what we find is we have added up these vectors. Let me name these vectors as P, Q, and R. See the direction of R. So we have this as P, sum of the vectors P, Q, and R equal to 0. They represent the sides of a triangle. They represent the sides of a triangle.
Right.
Hence, we have this result as the vector sum of the three, if we have the sum of three vectors taken in order, that is, they represent a triangle. That is known as triangle law of vector addition.
Right.
And in case if you find that there is a result which is giving us, that is when the three vectors are added, randomly any three vectors are added, A added to B, added to C, and the sum comes out to be a 0 vector, then they represent the sides. So the vectors represents the sides of a triangle. So this information is also to be used, like very often we'll come across this information where we'll be using it to solve certain questions. Right? So shall we move further now?
Yes.
Now the question is, what is A minus B? As we discussed about A plus B, now what is A minus B? A minus B is very clearly giving us this information that we are adding two vectors. Which are the two vectors? One is A, the other one is minus of B. So we'll add the two vectors, which is still the addition of the two vectors, that is A and another vector. But the other vector is opposite to the direction of the vector B. So how do we describe opposite? Minus B stands for a vector which is in line, collinear to the vector B, but it is in the opposite direction. So you can see that PR, it represents the vector B, then PR dash. This represents the vector minus B. That's the thing. You see that there's a straight line that we have. R dash happens to be a straight line where P is its midpoint. So PR vector represents B, the minus B is represented by PR dash vector. Is that fact clear to all? Do you think, Anuji, everybody has understood this fact?
I hope so, ma'am. And I'm hoping our viewers would be sending us their queries if something is not clear.
If there is any query, please do let me know. I'll try my best to clear it. Now you can see here, we had the previous vectors. This is vector A and this is the vector B that we had previously. We shifted this vector to this vector which is parallel. See, OQ parallel to PR. We shifted that vector. And so that the initial point of B coincides with the terminal point of the vector A, fine, and got the resultant as OR. Same thing we'll look for in this also, that is the addition of A and minus B. So look at this vector OA, this is A vector. So we have this result QO. QO stands for this link QO plus OP. That means it's from Q to P.
Right.
Now what is QO? It's minus of P. Isn't it?
Yes.
QO. QO is not in the direction of OQ. It is in the opposite direction. QO is in the opposite direction of OB, OQ, which says that that's a negative vector minus of P.
Right.
Now isn't that we have, that is its minus of B plus A is actually QP vector. So that is this resultant. This is the resultant that we have. So when you finally look at this figure, you will find that the parabola that we have is O, P, R and Q, which has two diagonals. One diagonal is OR, the same initial diagonal.
Yes.
There's another opposite direction, that diagonal, that is QP.
Right.
So that diagonal is actually A minus B vector. That means we are able to express the two diagonals in terms of A and B. One diagonal happens to be A plus B, the other diagonal happens to be A minus B. Got it?
Yes.
So this has to be understood because we have questions. I'll remind you children, we have questions which is based on this A plus B and A minus B fact. Okay?
Ji.
Because we have seen that A and B, we have made it as a parallelogram. So A plus B happens to be one diagonal, A minus B happens to be another diagonal. So what can we frame in it? We can get a statement where we can have the two diagonals can be perpendicular to each other. So when they are perpendicular to each other, that parallelogram has a characteristic. That is, it's a particular type of characteristics. So all this informations you will have to recollect what you have studied in geometry. Okay?
Ji.
Now we move on to the next point, that is position vector. Now this is the thing that you must have heard for the first time, dear children. ये सबसे पहली बार अपन सुन रहे हैं ये word position vector. Position, the word position is explaining something. Position of some vector. Vector means a quantity which has a direction as well as a resultant. तो ये direction and resultant आप कैसे refer करेंगे बताइए? जैसे आपने बोला एक प्लेन जा रहा है, प्लेन इज फ्लाइंग इन दिस डायरेक्शन ईस्ट, ठीक है, उसका डायरेक्शन है आपके पास, मैग्नीट्यूड डिस्टेंस कितना क्या है करके आपको कैसे पता है? आपको तो ये पता लगाना पड़ेगा ना वो कहाँ से स्टार्ट किया है जी. तो इनिशियल पॉइंट चाहिए ना आपको, रेफरेंस पॉइंट, राइट, एक इनिशियल पॉइंट. तो हमारे कार्टेशियन सिस्टम स्पेस में क्या है, वी टेक ओरिजिन एज द इनिशियल पी. ओके, विथ रेफरेंस टू दिस ओरिजिन we have described all the definitions. So this is the point, that was where the coordinate axis they made. ये सब बच्चों को मालूम है, जैसे कार्टेशियन सिस्टम इसके बारे में मालूम है. So we have considered a point in the space. P is now in the space, which has coordinate x, y, z. तो ये information everybody I think know it. ठीक है? Right. Now this is derived from the fact that that is the point that we have on x-axis, that is C, which is having coordinate x 0 0. The point that we have on the y-axis B, which is 0 y 0, and point Z represent having point 0 0 Z, and together the coordinate P is expressing x y z. ठीक है, तो हम किसके बारे में बात कर रहे हैं? P पॉइंट के बारे में, विथ रिस्पेक्ट टू व्हाट? O. सो P को विथ रिस्पेक्ट टू O से हम डिस्क्राइब कर रहे हैं, तो वी आर डिस्क्राइबिंग एज अ वेक्टर क्वांटिटी. दैट मीन्स वी नाउ हैव इट्स इनिशियल पॉइंट एंड द टर्मिनल पॉइंट. इट स्टार्टेड फ्रॉम ओरिजिन, रीच दिस पॉइंट P which has coordinate x y z. तो अब इसका लेंथ क्या होगा? व्हाट विल इट्स लेंथ बी? Length will be represented as OP, magnitude of OP, vertical bracket. So that's the magnitude. अब बच्चों recollect करो, it is looking, that is P actually is a vertex of a cuboid. So OP is one of its diagonal. तो opposite diagonal का length क्या होता है? Under root of x square, length square plus breadth square plus height square. So that is giving us root of x square plus y square plus z square, that is equal to the length of, or distance between O and P, which we are representing. There's a representation that its length is r. This is not a vector, it's the magnitude. तो हम उसका वेक्टर कैसे रिप्रेजेंट किया है? r के ऊपर बार डाल दिया. That's a vector quantity. Right. ठीक है जी. Now let us now express each of these quantities in the vector. That is OB जो है, that is length OB is y. Now if it is to be made into vector, what do? I just connect a vector to it which has unit vector. So what is the vector in that direction of B, which is in the y-axis? J. So y multiplied by j gives us a vector quantity in the direction of y-axis, OY. And AB is a line parallel to OX. Therefore, vector OC will also be parallel to BA. Right. So that way we have vector BA and vector OC, like they are same vectors, and hence BA happens to be xi, because OC, what is OC? O to C has length x, so the vector OC is xi. So it is AB, BA. So it's from B to A, so we have this vector as BA as xi. Likewise, we have defined the vector AP, which has zk. Fine? Ji. Now look at the combination of vectors that we need to see for OP as its resultant. That is, हमने start किया है O से, we have reached P. Now, how is the point P reached? If you look at the coordinate axis carefully, you'll find that that is the way that has been, the path that has been traveled could be like this. O से start करके we move on to this and reach A, and then A से ऊपर के तरह height में ले लिया, and that way reach P point, and therefore OP is the distance.
Right.
It could be any way, that is, you have from O to B, then move from B to P, that is also possible. I have taken up this path, that is O to A first, and then AP is perpendicular to the plane, it is plane. Ye AP, the point A, B, C, O, they are all in one plane, they are all in one plane.
All right.
If I take this point as A, then the point, the vector PA is actually a vector which is perpendicular to the plane. Can you visualize it?
Yes.
It is perpendicular to the plane.
Right.
That's how you find. So you find that the triangle OAP, you can see the triangle OAP. This is O to A and A to P. They form a right angle. That's the reason why I put this symbol. It represents a right angle triangle.
Right.
So this is also right angle triangle. So it's a right angle triangle. So OP vector is shown as the sum of vector OA and AP. Both have the OA, terminal point A, initial point of this is A. So this is added up to give the vector OP. Now how do we reach A point is the question, because it's point through B and C. So OA is through OB and then B to A. O to B and then B to A gives us OA vector. So that is how it has been split. So what is that vector B? We have it as xi. What is vector BA? This is yj. Everything, all details are here. We have the details here. Replace those values and you'll find that you have expressed the vector OP in terms of the points that has been referred as x, y, z, its position, the where it stands for. It's x, y, it's a particular point in the space. So we have given the reference of this particular point P as x, y, z. So we have defined this vector OP in terms of this reference point. Hence the word position vector. So isn't it a position vector that we have? Position vector of P with respect to O is xi plus yj plus zk. So we have expressed it in terms of x, y, z. That is xi plus yj plus zk. So that's the vector OP in terms of the position it has in the space. In terms of the position it has in the space. And the vector OP, in short, we can write it as R also. So these x, y, z, what are they? They are all scalar multiples. See, it's multiplied to vector. So they are known as scalar components along the axis, x-axis, y-axis and z-axis. And these components, xy, xi, yj, I cap, it is always, remember that if you say it I cap, only then you'll remember that it's a vector quantity. Otherwise, you will ignore the fact that it's a vector and unknowingly you will just write plain I. If I write this way, if I write simply xi, yj, they don't represent vectors. And dear children, आप लोग भी गलती मत करना, because ये वेक्टर है ही नहीं, तो हम किसके बेसिस में आपको मार्क्स दें? Any question asked on vectors, if you don't have a vector in it, आप किसके बेसिस में आप मार्क्स मांग सकते हैं? So that's the common error seen by the student in the examination. That is, vector को vector quantity लिखते नहीं है, because हम लिखते समय बोलते हैं, when you say, we just say it as xi, yj and all. उससे क्या है? We keep in mind कि I is an ordinary number I. It's not, it's a unit vector I. Keep saying unit vector I, unit vector j, unit vector k. That way you remind yourself that they are vector quantities and we have to write with a cap over it. That cap is a very important part of this. Okay. Now the question is, there is a vector OP. The representation, can you read this? You need to read every element of the question. The question says it is a cap over the vector OP. Cap over OP, sorry. Cap over OP. Cap over OP means this is a vector which has magnitude 1. The magnitude of this vector is 1. So we discussed this formula before. Remember, I had given this formula before. That is, any vector, any unit vector is actually a vector divided by its magnitude. Now the question of magnitude, how do we find the magnitude? It is square root of the scalar components. The scalar components, that is x square plus y square plus z square. So the unit vector OP will be vector OP upon its magnitude, which is 4i minus 12j plus 3k upon square root of 4 square minus 12 square and 3 square. I have picked up this number in particular because we all are aware of this 4 square and 3 square. 4 square, 3 square gives us 5 square, which is a Pythagorean triplet. So we get the answer as 5 square. Now 5 square further added to 12 square. This is set of another Pythagorean triplet, which gives us 13 square. So it is easy for us for the computation. So this is another information. I keep saying this to children कि जो भी numbers हमें computation के लिए use करना होता है या दिया जाता है question में, they are not random numbers. They have some specific relation. तो आप अगर उस रिलेशन को आइडेंटिफाई करोगे आप अपना टाइम सेव करोगे, क्योंकि दिस इज अ शॉर्ट आंसर क्वेश्चन. तो आप उस शॉर्ट आंसर में आपका टाइम निकाल रहे हैं, आप कैलकुलेट करने के लिए 4 स्क्वायर प्लस 3 स्क्वायर एंड देन उसके बाद उसको 12 स्क्वायर का ऐड करके फिर उसका क्यूब स्क्वायर रूट निकालेंगे. इट विल टेक लिटिल टाइम, but if you are aware of the relations of these numbers, you will immediately come across with the answer. So what is a unit vector? Just divide by it, that is vector divided by 13. That's what we have as the unit vector. तो यहाँ तक क्लियर हो गया?
Yes.
अब let's take up question based on the unit vector. ठीक है? How do we frame questions which are based on this? So the question that you can see is, find a vector whose magnitude is 7 units in the direction of this vector. So let us name all this so that we don't use the word this and that. Like I said just now, this vector. What is that vector? Let's name it. It's not mentioned in the question. हम question को हम frame करते हैं. मतलब solution लेने के लिए कुछ चीजें हम consider करते हैं. So that's what I have considered. A, vector A as this. It represents some vector, तो उसका नाम डाल देते हैं. Instead of using capital letters and using 2 letters, we can use small letter. हमने small letter A से represent कर दिया ये vector को. Now, as per the statement of the question, frame the step, that is the step that is required to go ahead. What is required? The information that we have is the magnitude of the vector that you have in the direction. That is the two vectors. That is, you are finding a vector B which is parallel. It's in the direction. What does that mean? It is given. What does that mean? They are collinear. So what relation do we require for collinearity? That is, the vector is proportional to the other. That is, B is a vector which is lambda times the other vector. And since its magnitude is given, we have the length of that vector B, which is 7. So let us now sum up the whole thing. That is, B vector is lambda times A. So magnitude of B vector and magnitude of lambda A will also be same. The magnitude of lambda A is nothing but magnitude of lambda multiplied by magnitude of A. And the information we have is the vector B's magnitude is 7. So this expression is giving us the value of lambda. एक equation बन जाता है and that equation is helping us to get the value of lambda. So बन गया ना हमारा vector B. Lambda we again I have again purposely taken up the number so that we don't waste our time in getting the values. We are getting a concept here, that is the vector in direction of another vector is to be taken up as B times lambda times the other vector. Okay? So we have found the other vector. Now let us go for the we have vectors joining 2 points, that is P and Q. So we have vectors joining P and Q. How do we take up that? P is a point in the space, Q is another point in the space. These are 2 points on the spaces. So P का coordinate क्या होगा? Obviously it is x1, y1, z1. Q का coordinate x2, y2, z2 होगा. Random points, they are random points. So how do we connect the 2 vectors or make a vector out of it? That's what we are seeing. Again, frame this in such a way that we are able to express in terms of their position vectors. P का पोजिशन ट्रिप्स हम ओरिजिन दे रहे थे O से हैं, लाइकवाइज Q को भी हम O से ले रहे हैं. तो हाउ कैन यू फ्रेम इट? रिमेंबर द ट्राइंगल लॉ. आप OQ क्या है? OQ is OP plus PQ. That gives us OQ. So from here you get PQ's value as OQ minus OP. Now OQ, position vector of any vector, is x2i plus y2j plus z2k minus this. Combine this, you'll get this relation x2 minus x1i, y2 minus y1j, z2 minus z1k. So therefore, a vector which is expressed in the space can be written as, if you have the coordinates of the vector, we can get a vector in that form. That is, P's coordinate is given and then Q's coordinate is also given. This P's coordinate is given. Suppose P is 1, 2 and 3 and Q happens to be 0, -1, 3. How do we represent the vector QP is the question. How do we represent the vector QP? It is QP means x2 here x2 was for Q and this was for this was a vector PQ. That is P to Q is final to initial. So what is final here? 1 P. So 1 minus 0, it is 1 I bar plus 2 minus of minus, that is giving us 3 times of J bar cap plus 3 minus 3 is 0 K cap. So what is the vector QP? It is nothing but I plus 3J and 0K, that is the height. Z coordinate, it's 0, that it is there in that plane. It's known as, it's in the XY plane. The resultant QP will be in that one particular plane, which is XY plane.
Bina ma'am, we have come towards the end of this session, and I would request you to tell our students in just 1 minute what is the most important thing in this topic. Very short.
The most important thing, as I have said from the very beginning, since it is a quantity which has, this vector is a quantity which has certain characteristics, that is, it has direction as well as magnitude. So magnitude will get the length, but direction, the arrow over the vector is a must.
Right.
And this is a very different thing, that it's how it is to be added. We have seen how the addition is taking place. It starts from one point to other, and the initial of the other will come to the terminal of the other. So the addition part, how did we take up? How are we combining? How are we taking up the algebra? That is, operation of these vectors are not like the ordinary number system.
Right.
There is a rule in it. So we need to follow these rules and we need to know the representation, and only then we can go ahead.
Right.
Do 2 or 3 times, you just go through it, things will be very clear. The terms that we have studied, all those terms we have studied for the first time. तो ये terms को समझने में 2-3 reading की जरूरत है. तो 2-3 reading के बाद everything will be clear with the practice of the questions.
Right.
Fine?
Right.
Like this question, that is AB vector. That is, A is any point which is represented as vector A.
All right.
B, a point in the space which is represented as vector OB is B vector.
So let's give the rest of the question to our viewers for homework, Dr. Bina.
Okay.
Yes. So we come to the closing of the chapter Vector Algebra. We had Dr. Bina Prakash with us, and I would really wish to give my thanks to ma'am for explaining the topic so well, connecting it to real life and explaining each and every term in detail. I am sure our learners must have enjoyed and understood each and every concept well. Thank you so much ma'am for joining the session.
Thank you. Thank you to all my viewers also.
Alright, so dear दर्शकों, हमने अभी मैथमेटिक्स क्लास 12 का चैप्टर वेक्टर अलजेब्रा पढ़ा, जहाँ पर डॉक्टर बीना प्रकाश ने हमें वेक्टर्स से शुरुआत करके सभी टर्मिनोलॉजीज समझाई, जैसे कि को इनिशियल वेक्टर, को प्लेनर वेक्टर, ज़ीरो वेक्टर. आई एम श्योर आप सभी ने वो सब कॉन्सेप्ट्स समझे होंगे. अगर कुछ कॉन्सेप्ट्स रह गए हैं, यू कैन एनी टाइम गो टू आवर यूट्यूब चैनल एंड चेक हाउ मैम हैज़ एक्सप्लेन्ड देम इन डिटेल. इसको इस तरह से भी दे सकते हैं दर्शकों, ये जो कॉन्सेप्ट्स हैं ये नींव है हमारी मल्टी स्टोरी बिल्डिंग की. अगर हमारी नींव स्ट्रांग होगी तभी हमारी जो मंजिलें हैं वो भी स्ट्रांग होंगी. सो आई एम होपिंग दैट यू स्ट्रेंथन द नींव ऑफ योर मल्टी स्टोरी बिल्डिंग ऑफ वेक्टर अलजेब्रा. साथ ही मैं एक और इम्पॉर्टेंट इन्फॉर्मेशन देना चाहूँगी आपको डियर दर्शकों. हमारी चौथी और सातवीं की नई टेक्स्ट बुक आ गई हैं अमेज़ॉन, फ्लिपकार्ट और NCERT की ऑफिशियल वेबसाइट पर। कृपया वहां से जाकर आप इनको प्राप्त कर सकते हैं। I also wish to give thanks to our Indian Sign Language interpreters who have been translating the entire session in the Indian Sign Language. Thank you so much. तो दर्शकों, अब हम आ गए हैं सत्र के अंत में। आज आपने केमिस्ट्री और मैथ्स के सेशन हमारे साथ समझे और पढ़े। आशा है कि आपने कुछ नया जाना होगा और आप हमारे साथ इसी तरह बने रहें, ये भी मैं आशा करती हूँ। मैं अनुगुप्ता, आपकी होस्ट, आपसे विदा लेती हूँ। नमस्कार। हमसे जुड़े रहें, सीखते रहें।